Alrighty. Well, hey, good morning, everyone. Welcome to the Monterey Bay Aquarium and the Monterey Bay Aquarium Research Institute's social media feeds. We are live on YouTube, on Twitch, on Facebook, on Periscope, on Twitter. We're out there in the world, everybody. Hello, I'm talking here in the middle. My name is Patrick. I work at the aquarium here in social media. If anything breaks during this broadcast, it'll be my fault if we're suddenly streaming invertebrates out in the bay. That's on me. So I'm here in the middle. Over to this, I'll never be able to see this side of the screen. We've got the better half of the social media team. There's Emily over there. Hey, Emily. Good morning.
Hey, good morning, Patrick. Good morning, everyone. Or I should say, shallow, everyone. It's good to see everyone here this
Oh,
morning.
that's a new one. This should be fantastic.
Shallow.
And then all around us here, surrounding us, are amazing folks from the Monterey Bay Aquarium Research Institute. I've got Cassie over on that side, Susan right below me over here, and then we've got George over in the corner right there. And these folks are going to be answering your amazing questions in the chat live here, and maybe even answering your questions here live on the stream. But I wanted to present to you all our very, very special guest here today. We have special guest ROV pilot extraordinaire Ben. You are live here on screen. We've got Ben Erwin. Everybody, say hello to the fine folks online. Ben, how you doing?
Hi, everybody. I'm doing really well, Patrick. Thanks.
Awesome. So it looks right now like you are at sea, but you've got some green screen trickery that you're going to be using for us today, right?
Yeah. Got my green screen set up.
Cool. All right. Well, I'm going to try to remove all of the different Zoom menus that I had up on screen right there. But so just before we get started, before we talk to Ben, Ben is going to be guiding us on an amazing dive into. Oh, and we've got we've got a small child joining us. Hey. Oh, no worries. We are, of course, still streaming from our respective living rooms while we're just closed for this pandemic that we're in. But this brings us all together. We're going to go on a dive into some deep sea tech here, some really cool stuff here from Ben. But first, let us introduce the Monterey Bay Aquarium Research Institute and our colleagues over there. I'm going to refer to them as MBARI the rest of the time. So MBARI is an amazing, amazing facility that is located about 20 miles north here of the aquarium, and it is right at the mouth of an amazing, amazing natural feature, which is the Monterey Submarine Canyon. You can see it here on this animation. We're in Monterey, waving at Moss Landing over there. And right there at the head of that canyon is where MBARI sits. And this Monterey Submarine Canyon is essentially like the Grand Canyon underwater. It's a mile deep from the rim of the canyon down to its deepest point, and there's another mile of water stacked up on top of it, which means that out at its deepest point, it's about 2 miles deep. You can see here fingers of that canyon extending out over towards Pebble Beach and Carmel, but going many, many miles, over 60 miles out to sea. And that's what MBARI is up to with its research a lot of the time. We have here the Rachel Carson in the Moss Landing Harbor. You can see there the power plant in the background. It's very iconic. You can see from all around the bay. That's the Rachel Carson, one of the research vessels, and here's the research vessel, the Western Flyer, that we will be talking a lot about, because on board the Western Flyer is Ben's ROV, the one that he pilots all the time. This is the ROV Doc Ricketts, named for the John Steinbeck character and the famed biologist that lived here along Cannery Row. And ROVs like this Doc Ricketts dive down into that deep sea with loads of scientific equipment and the cameras that are going to be allowing us to, that have allowed us to show you all of the amazing animal life that we've talked about in previous broadcasts here of Mysteries of the Deep. You can see there that ROV arm is moving around. The lights are on. It's piloted. That's what Ben is up to, and he is going to be talking to us a little bit more about that. If I can nail this transition directly to you, Ben. So Ben, there's your baby there up on screen there, ROV Doc Ricketts, and there it is behind you. Can you tell us a little bit about what your job is at MBARI and that amazing piece of tech that you get to work with?
Yeah, so this is the Doc Ricketts vehicle. It's it's called an ROV, a remotely operated vehicle. Uh, Doc Ricketts is rated to 4,000 meters depth, so that's just about 2.5 miles deep we can go. We have it's a electro-hydraulic vehicle, so that means there's a big electric motor that turns a hydraulic pump, which gives us power to move the thrusters and the arms and other actuations on the vehicle, like the doors on the D-sampler and things like that. We have fiber optics that go down an umbilical that attaches to the vehicle. So that's what we use to transfer data from the vehicle to the ship in real time. And yeah, I think there's 6 fibers right now. So that allows us to do HD video and Ethernet and things like that. And then we have 2 big arms on the vehicle as well. See on my screen, you can see here, we have these 2 robotic arms. This one on the port side of the vehicle is a titanium arm that we use. It's called the Schilling T4. And this arm is basically a very strong arm that can lift a lot of weight and do a lot of heavy work, but it's a little less dexterous than our craft one on this side, on the starboard side of the vehicle. This arm is it's an aluminum arm, but it's very dexterous and nimble, and we can do lots of really fine detail work with that. So between the 2 arms, there's not a lot we can't do underwater.
That's awesome. Yeah, I've got some video going on in the background right now of the Doc Ricketts, I believe from when from your dive where you were filming each other, the ROV Ventana that we've talked about on this program before, and then Doc Ricketts there together. Can you tell us a little bit, just before we go to the audience questions, which I'm sure there are many, many audience questions out there, but Ben, can you tell us, how does one get into this kind of line of work? How do you get this type of job? Obviously, you've got a green screen going for the Zoom call and everything, so you're used to wiring a whole bunch of different things together. But tell us a little bit about how you pilot something like this and how you get into that kind of work.
Well, sure. Well, my background is in industrial electricity, so basically an electrician. I just have an associate's degree from Long Beach City College, where I went to school. And while I was at that school, I found a robotics competition that was run by MATE, which means the Marine Advanced Technology Education, I think is what it stands for.
Yep.
But MATE would set up these competitions every year, and I fell in love with that concept of building a robot and competing especially underwater. It added just this crazy dimension of challenge to it, and we did really well. One of the years I was there, and I got an internship basically with Bob Ballard, who's found the Titanic wreck. I guess that's his claim to fame.
Yeah.
So I spent 2 seasons out on their boat in the Mediterranean, cruising around looking at volcanoes and shipwrecks and stuff like that. And so I was hooked after that. I couldn't stop. So
that's awesome. So you got to go look for sunken treasure with Bob Ballard from Titanic.
Yeah, pretty much.
That's awesome.
It was great. Yeah.
Cool. Well, here, let me go to Emily real quick. Emily, let's go to the first few questions here for Ben. What do people want to know about your work?
Well, first of all, a lot of people are really excited that you have had the chance to work with Mr. Ballard there. So lots of people excited about that, just like you. But Ben, you're talking about this incredible instrument that we have to go down into the deep sea to record all of these amazing animals and the geology and everything down there with such a robust but kind of delicate piece of equipment. How do we keep it safe down there from all of those different elements? A lot of people are like, well, wouldn't it rust down there? What about the pressure down there? So how do you build a piece of equipment to withstand all of the challenges that come with going to the deep sea?
Oh, wow. Well, yeah, first things, it's not cheap, that's for sure. But uh, all these things come into play. And so the materials we use on the vehicle are mostly aluminum, because aluminum has really great corrosion resistance. And so it's also very strong. And it's easy to work with. So most of the frame on the vehicle is all aluminum. And then there are other processes we use to mitigate the corrosion even on the aluminum. And so the rest of it, like these housings here, I don't know if anybody can see these, but it's our 1-atmosphere housings that contain all the really delicate hardware, like the fiber optics and other computer boards and things like that, and power supplies. Those can't see pressure, so they're in a 1-atmosphere housing is what we call it, and those are typically made out of titanium, and it's just these big titanium tubes with all the electronic stuff inside, and then we connect to those with really expensive cables and connectors that can go off to these individual lights and cameras and things like that. And that's how we pass the signals around. But yeah, everything is it's an order of magnitude more complex when you start adding not only pressure but also waterproof, making it waterproof, because yeah, typically electronics and water don't mix very well. So,
Right.
but there are other things we do, like we have pressure tolerant houses as well, housings. And what we'll do, like for just general power distribution and signals and things like that, we'll put them in these pressure tolerant houses and fill it with oil. And so those actually see the 6,000 psi that is kind of typical at 4,000 meters, and so we crush that with that much pressure. But the typically, like, wire doesn't care if you crush it. so that's how we get at least a little bit cheaper in some of the ways to wire the vehicle up.
That's fascinating. Well, and especially yeah, I just wanted to ask a little bit more for you, Ben. That salt water, that drop of salt water on electronics, we've all like seen it on our phones or on, it's like that particular issue of salt water and just water in general and electronics is really difficult for just about everything, but especially going into the deep sea, where you have not only this medium that could fry everything, but you also have the pressure and all of that stuff. Can you describe a little bit about what it's like to be someone working in two worlds that seem like just really at war with each other, with electronics and salt water, because it's really something I think a lot of people don't think too much about. Is, you can kind of send things up into space a little bit easier than you can send things into salt water, right?
Yeah. I think the bigger problem in space is heat buildup. Or I think it's hard for them to actually get cooling up there, even though it's super cold. There's not a lot of ways for the heat to get pulled out. But anyway, for us, it's mostly, yeah, how do you build a housing and then seal it so that it can withstand the pressure and the water. And it's basically there's a lot of engineering involved as far as like understanding how O-rings work, and then there's like typically at some depth the pressure housings we have are just metal on metal, and so it's machining, it's tolerancing the metal so that it's like glass, and basically the two metal halves clash together. But I don't know, it's just a lot of work. It takes a lot of teamwork.
Yeah, I can imagine. Here, let's go back to the gallery view just to say hello to everybody. Thank you so much for all of your questions. We're answering them furiously, but I'm going to go over to Emily. Emily, what kind of questions do the folks have out there for everybody?
Yeah, so Ben, when you're out there studying the deep sea, how long do those missions usually last? And what's the longest you've ever spent at sea before?
Oh man. Well, at MBARI we typically only do 12-hour days, and then the Western Flyer is really only large enough to do like 10-day trips, 12 maybe 12 max. But we typically do between 5 and 7 days, just to keep it nice and comfortable. And then we do 12-hour days. So we wake up at 6, and then so we start the morning at 6 a.m. and end we're on deck at 6, usually by 6:30. So it's not too bad that way. The longest I've been out to sea is, I think it's with Ballard, it was like 50 something days, which is
Whoa.
It wasn't, yeah. I know guys have been out much longer than that. So, but it was, yeah, that was a lot of fun because we're still in the Mediterranean, and so we got to stop at a lot of really cool ports, along like in Sicily and Spain and all these other really interesting places. It was awesome.
So this experience of quarantine, probably very familiar to that amount of time spent at sea, or just
yeah, except you get internet. That's
there you
fun.
go.
Yeah.
Nice, cool. Okay, I'm gonna put Emily back up on screen. Any more questions here for Ben?
Yeah, absolutely. Sorry, Zoom was telling me that I was still muted. I was not. Zoom, thank you very much.
Yeah, come on.
Come on, technology. Well, speaking of the technology, Ben, what does it actually take to operate the Doc Ricketts?
Yeah, quite a bit. I mean, and I can swap over to another screen here in a sec, but there are sensors all over this thing. So we've sensors not only for science, but also telemetry sensors that tell us the state of the vehicle. So like voltage and the current we're drawing. On the electrical side, there's the fiber optic bandwidth and stuff like that we can monitor. There's the video signals. I think we have 15 analog video channels, and then we have we can do 1, 2, 3, about 4 HD video channels now. And it's changing all the time. So now we're even doing able to do 4K and stuff like that. Now that they're starting to develop these new cameras and stuff. So yeah, there's a lot of technology involved. Like every piece of equipment on here is just like, it's packed with sensors, packed with technology, and it's kind of mind bending to try and understand all of it sometimes, but yeah, it's outrageous. And then that's just the vehicle side. Then there's the ship side. So like, I'll switch over to this. This is a control room. So basically, like that's my boss, Knut. And he's sitting in the pilot's chair, and he's got a joystick there, and there's touch screens over here that he can use to turn lights on and off and stuff like that. So there's a computer system topside that we have to know about, the software that drives all that stuff. There's all the video signals and the switching, like how to send the video signal from this monitor to this monitor, and then the data management stuff and the tracking and CTD stuff. It's all over the place. It's just so much technology, but
this looks awesome, by the way, Ben. I mean, we were talking about like deep sea tech weatherman status, but I mean, look at that. That's awesome.
Right here.
Yeah, that's perfect.
Yeah. So people are also really excited that it's the brooding octopuses that are behind you.
Oh yeah.
On screen. It's the perfect scene to capture there.
Yeah. This is I think it was last year we were at this one. I think we were here earlier this year actually too. I think, but yeah, we're doing. This device measures, I think, oxygen or something like that. So we're trying to get temperature and oxygen measurements near the octopuses. But yeah, all these screens, we got like multi-beam sonar here, tells us how close to things we are. It's sort of like a sonogram, like, um, and let's see, what's this one? This is a regular scanning sonar. So it's just does a swath, a beam swath every once in a while. Tells you what's out. We get quite a bit of range on this one. So this one's like a short range, and this is a longer range. And then vehicle telemetry right there. That tells us that the screen tells us what everything on the vehicle is like, oil levels and voltage, and also the orientation, so how we're sitting in the water. And then we have tracking further down there, so that tells us where we are in the world and in relation to the ship.
Here, I think, here, Ben, stay right there and tell us a little bit about the Octopus Garden, because I just found the octopus video, and so I'll play you together with that. Oh, this is awesome.
Oh.
Yeah, can you tell us a little bit about what it was like to encounter those octopuses?
Yeah, here, I'll do one better. So let's try this.
You're going to do one? Oh.
So we did a model of one of the sites.
This is so cool.
So
yes.
This was one of the ledges that we filmed, and so there out at the ridge, it's really kind of on a cliff. All these things, like all these little vents and stuff. So they're scattered all over the place, and so you can see how they're just kind of congregated, and there's venting all along these cracks like this. And so Rickets would fly in sort of like around here, and then we'd land on the ledge, and our butts kind of out there hanging in the wind, just floating, and we'd kind of down thrust on the ledge and do all of our work, trying not to disturb them too much. And then yeah, this ledge is we've done a lot of work on this particular ledge, so this is why we were able to film this one.
Now, can you?
It's crazy. They're everywhere. For like, I mean, there's like tens of thousands of them all over the place, and it's hard to even say like how big the area is. It's because I mean, you're like in a dark room with a flashlight, and you're trying to put it together in your mind what the whole area looks like. So it's kind of tough, but yeah, it's mostly like cliffs and ledges that they're stashed on, and there's just thousands everywhere. It's cool.
Wow. And can you tell us a little bit about what type of wizardry you just pulled off there? Because that was something that we definitely wanted to talk to you about. One of the titles here of this talk here is about VR and other things happening in the deep sea. So I've got the video of the octopuses that you helped film there in the background, and then but can you tell us, and now that you're back up on full screen, tell us what is going on behind you there? What did you just do?
Okay, so well, this is called structure from motion reconstruction. So or photogrammetry is another term used. But basically, what we do is we take the vehicle and film an area and basically try and get as much coverage of it as we can. And then I take that footage and take the screen grabs, like one every 30 frames or so. And there's software out there that you can load these frames into, and it will basically guess or estimate. It'll try and pixel match between two frames and say, okay, I think this pixel is in this place in space, and it'll put a dot there. And it does that millions of times over. And so it creates basically what they call a sparse cloud, and then you go through this process of cleaning up these sparse clouds and make a dense cloud. So it looks almost like this, but it's all just points in space, and then it'll it'll connect the dots and create a kind of a skin, and then the texture goes on the skin. And so that's what this is.
Wow.
That's how we make these 3D models, and it's all just about getting good coverage with the camera, and there's some other tricks involved with lighting when you're underwater. It's important because there's you have things like detritus that can throw off the software. So there's some cleaning up and things to do with it. But wrong screen.
How long would it take to create that particular model?
So this one actually didn't take very long. Let's see. There's another one I have here.
And this website, by the way, is Sketchfab for folks.
Sketchfab.com.
Yeah, and they can find all these models, right? Sketchfab.com/MBARI.
That's right.
Yep.
Yeah, and they're free to download for anybody. You can pull them into like a game engine if you want, if you're making a video game, or if you want to just look at them in VR. There's a little option right down here in the right hand corner. If you have a VR headset, you can just click that, and it puts you right in the scene. And so
wow.
And you can see they're all scaled, so they look about what their actual size is. So this one took actually the software's gotten much better in the hardware as well. So like the computer I use is very powerful, and so I was able to do this one get the majority of the rendering done in a day. I think I had 1,000 images used on this one.
Wow. And you were saying that this is true to size. So could you do a 1-to-1 with you on the green screen and those coral there? Because those coral are absolutely massive, right?
Let's see. I can try it.
By the way, we're no longer streaming to the audience on social media. This is just for me. Ben, please do this. This is so cool.
Yeah, this is just for us.
Yeah, this is just for us now.
Okay.
Yeah.
So let's see. I think it'd be about that, because I always like have to watch out. I always bang my head on this thing.
Okay. And what is that? What is that there behind you? This is
an elevator which has a camera on there, so it's hard to see. This one didn't render very well. We couldn't fly the vehicle in front and get good imagery of it, and so it kind of broke down in the reconstruction. But what this is a camera, and so the camera's on a rotator, and so basically we go and plug Rickets into it. Well, first of all, we drop the elevator off the ship. It sinks to the bottom. We pick it up with the robotic arm on Rickets and drag it over to the stone here, this big rock. And then we tried to orient it, and then we'd plug into Rickets into it and send the video from the camera up through Rickets, and get the position just right. And then we disconnect Rickets from it and then fly away. And basically,
wow.
It's still there. It's there for like a year. It's going to be there for a year, and at least. And then we'll drop the drop weights that are down here, and it'll float up to the surface, and then they'll download all the images. And what they're doing is looking at this little section of sponges and coral and stuff like that. But yeah, this is a big rock. I think it was 25 meters long by 16 meters high. So
okay.
It's pretty big. There's
and so that is, when you're standing there next to that camera, you picture in picture right now, that's approximately how big those coral fins are behind you.
Yeah, these coral, I mean, I've tried to ask them how old they are. They're not, I don't think they're really sure, but usually these coral are like hundreds of years old. Maybe Suze knows that better than I do. But these are like ancient coral, and they're huge. They're between 6 and 9 feet tall. They're huge.
Wow.
And so it's really interesting to and just amazing to go down and see this. And the amount of the colors that are on this rock are incredible too. I mean, it's just I don't know. They really are pink like this, and these sponges are really yellow and green, and it's just amazing.
Yeah, really here cool. I'll pull up some footage there from Davidson Seamount so people can get a little bit of an idea.
And if you want me to chime in, so those pink corals, they're called bubblegum corals. and their scientific name is Paragorgia. And they are like the size of small trees, I always say, but they can be over 100 years old, which is amazing. And then those sponges, we call them Picasso sponges because of their color and just the shape. They're so beautiful. And I believe their scientific name is Staurocalypsis.
Huh.
Nice. Yeah, here, I'll put Ben back up on screen. You've got a Picasso sponge and a Galatheid crab walking on it right now in the background. And then here, I'll put up that Davidson Seamount community there in the background again. And you can see, I mean, it looks basically like, is this the exact same rock?
It might be.
Wow, that lined up perfect just then. I'm blowing my mind over here. Again, sorry everybody who's tuning in to maybe ask Ben a question, but he's ours for the time being here to nerd out with. This is amazing.
I think this rock is the Sir Ridge rock.
Sir Ridge, yeah.
Where they're actually studying. They're doing the Coral Observatory. I put a link in the comments to a story about that. And then your footage that you're showing is on Davidson Seamount, but both of these seamounts are within the Monterey Bay National Marine Sanctuary.
Okay. That was just too cool to have both there at the same time. Let's see.
Here.
Oh, here. Oh, cool. Here, sorry, let me put Ben back up. And maybe, you know what, maybe we'll indulge. Emily, let's go to the audience. That was amazing. Can you tell us what do the folks want to know?
Oh my gosh, there's so many things that we want to know right now, Patrick. Okay, we'll start with some of the ones that that we got a little bit earlier here. So Ben, are you limited in what types of sensors and hardware that you can put on the ROV? And if so, what would you, like, ideally in a dream world, love to have on an ROV like the Doc Ricketts, but haven't figured out quite how to put on there yet?
Yeah, you are kind of limited in some ways. There's like every sensor you put on you have to figure out how to make it either waterproof or pressure tolerant. So I'm not sure. I mean, our engineers do pretty well. I can't think of something that offhand that we haven't yet been able to do. Usually if you spend enough money and put enough brain power at it, like, you can solve these problems. But so far we've done pretty good. Like, what I would like to do, just because I'm a big VR nerd, is yeah, there you go. George put 4K camera, but that's coming in October, we think. So we're close. What I'd like to do is do videogrammetry. So basically have a big setup on Rickets that can film multiple angles of an object, and we can do sort of the structure from motion recreation stuff. But like, so we make a 3D model of moving objects. So we can have a 3D model of a fish swimming, for instance, and you get all sides of it. So that would require some really crazy, like, rigging and cameras all over the place. But I think that's more the future. So and I think Kakani's kind of working in that direction too. So it'll be fun to see where she goes with some of the stuff her and her team are working on. But yeah, one of the things we're looking to do is well, actually we finished it. It's a VR camera. I'll pull that one up really fast. So this was on in February, just before all the COVID-19 stuff happened. And so, like, I just installed it. We just finished this camera. We just installed it. We're getting ready to go out like the next week to go do some filming and do some science. And they shut everything down because of the pandemic. So I had to pull this off, and haven't been able to get my footage yet. But hopefully soon we'll get back out there and do it. But this is really cool.
You've been doing a lot of VR of the squirrels in your backyard then.
Yeah.
since?
I have. Well, I haven't even been able to do that. So.
Oh, I'm sorry.
No, so it's anyway. So this camera is going to be really fun because it has two cameras that are close together. So we call that interpupillary distance. Are really close. So they kind of mimic the human IPD. And so when you go, what's unique about this camera is that it has a live feed. And so we can put a VR camera or VR headset on our heads and stream the video source from these two cameras live to the headset. And so these are also 180-degree lenses. So you can, like, if you sit in one perspective, you can turn your head in 180 degrees without a pan and tilt, for instance, in real time.
Whoa.
And look and see things in 3D. So we're gonna see how that works. We're also looking at tying in telemetry overlays with that. So some real Iron Man stuff, so that there's we just had a team from UCSC make a really great app for us that can tie into our VARs, our video annotation, and RS. I can't remember what RS meant. Sorry. But
reference system.
Reference system. I can never remember that. It actually can tie into VARs, and you can take. We're looking at using this camera to and calibrating it, and then you can take frames from this camera and get actual sizing, like actual good usable sizes from just from the imagery. So we don't need anything in the frame. You don't need lasers anymore. It's just these. We're pixel matching and on a calibrated known kind of optical plane. So
that's amazing. And you mentioned Iron Man. I would be remiss if I didn't offer you the opportunity to suit up as Iron Man if you felt you could pull it off here live on stream. Yes.
We also have a suggestion from Twitch that as the deep sea Iron Man, you rename yourself Tony Shark.
There you go, Tony Shark.
I love it. Yeah.
Well done. No, so if that's the view of you as Iron Man with that, and you have the VARs system is who you would talk to in the middle. That's amazing. And just a quick question: would that replace piloting from the screens for you as the pilot, or would that just be an extra tool at your disposal in case you needed it?
Right now, it's an extra tool. I mean, we don't really know exactly what to expect with it. It's never been done. Not with a VR headset. It's been tried with like 3D TV and stuff like that, and those weren't particularly good. They made people sick. You couldn't change your perspective. It was just 3D, like one fixed perspective in 3D, which this is as well, but you can at least turn your head around and look at things. And so we're looking to see how this can tie in. When we're on bottom, for instance, this will give a natural sense of context, like and spatial awareness. So because it is in 3D, you can look around and just like your brain does naturally, you can get a sense of depth from the distance of the cameras. So so that's what we're hoping to try out. And with the video, the overlay stuff, we can try tying in like not only vehicle data, but also kind of where, like geolocation. We can overlay like the 3D models in a certain area if they're geolocated. We can do all kinds of really stuff, like the sky's the limit. So this just provides us an opportunity. Like the camera will provide sort of the backdrop to all these computer vision and nerdy overlay things
that's awesome
you see in movies.
That's so cool. Here, let's go. Do you want to show us that whale model that you had up? I've got some whale fall video here in the background as well. So what can you tell us about that model that you had up a little bit earlier?
Yeah, so this is the Rosebud whale fall. This was a huge whale. It was a fin whale who unfortunately she was struck in Southern California, just off of San Diego several years ago, and she was struck by like a tanker ship, and it broke her back, and she ended up dying. And I guess she washed up on a beach, and scientists found her and wanted to do some science. So they pulled her off, and was able to sink the carcass with a bunch of weight. So there's like 7 tons of like steel and
Oh, wow.
yeah, like that's what all this stuff is. It's like it's all chain and weights and stuff like that. So I think it was late last year, we went down there, or maybe no, it's early this year. We went down there, and I was able to do a reconstruction of Rosebud, and turned out really good. There's so just for reference, Doc Ricketts is about as long as her head right here.
Wow.
So this is about 12 feet long. So it was interesting flying over top of this during the reconstruction. I just noticed that this was the width of our porch, like the span here, and the length is definitely, it's about, so her head is just the size of Ricketts. That's how big these creatures are. Just phenomenal. And like the vertebrae are the size of tree trunks. It's insanity. So,
Wow.
so yeah, so they're doing a lot of science on what happens to these carcasses when they sink. They're a huge carbon transport, and can offer food to a lot of like deep sea communities for years and years. And like there's all these worms that grow on it, these pink fuzzy bone worms. So, and you can see anemones grow on it, and there's fish. And they also catch a lot of trash too. It was really depressing. We saw a bunch of trash, so much plastic. Like that's a plastic bag. There was like, I think we pulled like 3 or 4 Mylar balloons. Those are awful. So don't buy those. My suggestion.
If you want to make sure that the animals in the deep sea are having a happy birthday as well, balloons are out.
Here's one of the balloons here. It was sad to see that much trash strewn about. But yeah. Anyway, sorry for the downer.
No, it's reality. We got to talk about it. Let's see. Let's go to, that is so cool, by the way, just flying around. The website again, if you are just tuning in for these models, is sketchfab.com/MBARI, and these are free to download. You'll be able to put on your VR headset if you have one and walk around Rosebud, the whale. Amazing. Let's see. Let me go to Emily for some audience questions. 45 minutes, by the way, Ben. So far, doing great on time. Emily, what do the folks want to know?
Oh, there's been so many questions, but Ben, you mentioned that you are a self-proclaimed VR nerd. Is this something that you learned all about when you were on the job, or were you a VR nerd way before?
I've been a nerd for a long time, but for sure. But no, I've always had an interest in this in VR, and so I've always wanted to integrate like a VR camera and headset situation on an ROV ever since my competition days, and so this was sort of my chance. And when in like 2017, they really started coming out with like the commercialized VR headsets, like the Oculus Rift and things like that. And so I went out and bought one, and I took a class in Unity. Like Unity is a game engine, and so I watched a bunch of YouTube videos, and I pulled in one of Kakani's like larvation housings. So she gave me one of her models of the larvation snot house, and I pulled that into a game world, and then put like set it up for VR so you could walk around inside the larvation house. And then like I made like a bazooka that shot plastic particles, because at the time she was doing plastic particle work on them to see like if they'd eat the plastic. So and then I'd take this out on the ship. I'd play around in this environment, and then like while we're out on the ship, stick people in the headset and they could walk around the larvation and things like that. So it was fun. I started doing that, and then I started meeting people in the community, in the VR community, in the nerd circles, that were looking, or that were making underwater cameras. And so I think it was 2018 we wrote, or 2019 we wrote a proposal to build one of these deep sea VR 180 camera systems, and it's kind of just grown from there. But we'll see where it goes.
That's awesome. I had the larvation up there behind you while we were.
Oh yeah.
While you were talking, if you want to learn more about the snot palaces of the deep, everybody, you can go to MBARI or the Aquarium's YouTube channels, and that was with Kakani. So look that up. It was a really, really fun episode. Lots of really cool new science and visualizations there. And shout out to you, Ben, for the piloting of some of those lasers. That's actually here. I'll put here.
Oh, geez.
If I spotlight myself and I hide a little bit, you can see the mini ROV and then the laser arms and then the mucus house there of the larvation. This was from Kakani's talk.
Oh yeah,
actually, can I just chime in really quick to let you guys know that tomorrow Wednesday, we're putting Kakani's high resolution 3D model on our YouTube channel.
Oh,
and
awesome.
It fly around and then it flies through and into the mucus house. And that high resolution model is going on MBARI's Sketchfab as well. So be sure to check it out tomorrow.
Awesome. Okay. Let's see. Emily, any questions for Ben here?
Yeah, Ben, would you mind talking a little bit about some of the different tools that we can attach to the Doc Ricketts, ROV Doc Ricketts, in order to collect animals from the deep sea?
Yeah. So this is what's really cool about Doc Ricketts. So on my screen, I have the vehicle up, but there's this lower section here. We call this the sled, the tool sled. And so it takes maybe 40 minutes to unbolt these sleds on the bottom and swap them out for another sled. So the one in this picture is called the benthic tool sled. And we have the D-sampler tray in it here. So these are called D-samplers. They're basically little aquariums that have doors that are hydraulically actuated that close. So we'll fly along, we'll push out this tray, and then we'll get an animal lined up in it and catch it, and then close the doors. And then it's a self-contained sample. We can bring that to the surface and they do their science on it. There's also like a suction hose that's in here that goes back to we have 12 large suction tanks in this carousel back here, and they rotate around kind of like on a chain. And then we have a mini sampler as well. So that does, I think that's 8 samples. So we can do 20 discrete suction sampler samples, and then we can do 12 D samples, and that's in one trip. So that's pretty good for science applications in terms of catching animals for science. We have other sleds that we can swap out very easily for like doing midwater stuff, like like benthic imaging, ocean imaging, mapping and stuff like that. So there's like laser or LiDAR systems that we stick on there with multi-beam, and then we can do these really fine gradient maps of areas, and they can do it basically makes a 3D model, 3D map of an area. It's really cool. let's see, what else is there? There's the Vibracore, so that we can take, it's this big heavy machine that sits on the front of Rickets, and we can send, I think it's 7 or 8 feet tall tube cores down, and it basically just shakes all the way down into the mud. And they can do, they can get a good history of the soil in that, or the sediments in those areas when they do that. Let's see, what else? There's PIV, of course, like Kakani, got to give her that shout out. So we carry that thing in the arm all the time, and can we get it set up to fly on those larvaceans and siphonophores and stuff. It's really hard flying. What else? Yeah, I mean, there's the sky's the limit. Basically, whatever we can, if it takes Ethernet or serial or video, which pretty much everything does these days, we can pretty much make something to fit it. So
how difficult, just as how difficult is it for you as the ROV manipulator to get the USB A in the right way every time? Do you still have to like flip it around? I'm sorry, it's a terrible connector joke.
It's always hard. Yeah, trust me.
Okay.
It's never easy.
Never easy. All right.
Yeah. So same with the Ethernet. Always goes in upside down, right?
Right.
So.
Well, that was awesome. I had the Vibracore going on there behind you, and a few other sampler bits there. Back to Emily for some questions from the folks.
Okay. So, Ben, when you're on these missions that last for, days, maybe weeks out at sea, how frequently do you have to do maintenance and check on all of those different sensors and different sampling equipment and all of that on the ROVs?
Oh, yeah, daily. That's a daily thing. So, fortunately, like there's 5 pilots on Rickets, and we've been there. We've each been there for years. I've been here like 8 years now. So, and I'm the new guy still. Compared to the other pilots, they're all great, and so everybody knows what's happening with the vehicle all the time. It's like it's just second nature to us now. If something breaks down or if something needs maintenance, we just go. We kind of have a sixth sense about what it's going to be. But yeah, it's a daily thing. We go around, we walk around the vehicle, and our eyes naturally go to the problem areas. And we check things that need to be checked. There's before every dive, there's a pre-dive process. Takes about 20-30 minutes to do, and we go around, check all the connectors, like literally every connector, because as Patrick said, like the one drop can make your day really bad. So so we make sure everything's tight. We look for oil leaks, for instance, like if the hydraulic oil is dripping out or something like that. We'll do all these types of checks in the morning, and then we do another set of checks at night when we come back on deck, just to make sure nothing had happened or loosened up during the dive, which can happen as well. So yeah, but it's a constant thing. I mean, it is a full-time job just keeping it running, because it's such a difficult environment to work in. Things change all the time. So yeah.
And if it's not too traumatic, what's the biggest thing that has broken on a dive? I don't want to make you revisit anything that's too difficult.
Well, I'm an electrical guy, so it's always the electrical stuff is always the worst, because for me, at least in my opinion, because I'm an electrical guy, but it's the problem with electrical problems is that they're often intermittent. And so like if something gets squeezed at depth and then breaks because of the pressure, like just because the pressure is like leaning on it or something like that, it makes a disconnect, then it's really hard to find where those problems are. And so yeah, like one time me and Brian, me and Brian Schaefer are the 2 electrical techs on Rickets. There was a power supply with a connector that was just kind of barely like making connection. And so like on the surface, it was fine, but you go down a couple hundred meters and there was just enough play in the housing, in the 1 atmosphere housing, that it would like tweak the wire or something. Uh, and and so we'd go down a couple hundred meters, and then all the lights, everything would shut off. It's like the vehicle's dead. And then we'd come back up and we try to restart it near the surface, and it would come up. And so what we had to do, we traced the entire system out. We tried to figure out how, every time we'd open up the pod, the main electronics housing, and try to just diagnose where the problem was, like it would shut off. So like we get out to like this spot, we'd be able to get probes in there. Okay, all right, what's the next spot? We pull out a little more, it would shut off. So we started measuring, we started measuring how far back it was that we were able to pull the housing before it cut out. We finally found the problem was this silly little connector.
Oh man!
Made the whole vehicle shut off. And
do you have that? Do you have that connector mounted on a wall somewhere, like you slayed your beast, basically?
Yeah, we actually have like a wall of shame. Actually hangs right above our table in our shop.
Oh,
so, yeah,
awesome.
that connector is there.
Oh wow.
Yeah,
that's so cool.
That's been the worst one for me, but yeah, there's been other problems. I guess on Tiburon, I guess the bolts, the previous ROV that was on the ship, I guess the bolts that kept the tool sled on, there's only one big bolt or something like that. I guess that broke off, and the tool sled came up swinging beneath the vehicle, and Whoa. It was only the hydraulic lines that was keeping this whole thing on. So, yeah, there's been all kinds of crazy things that have happened, but
wow.
So far, not too much. Rickets has been an awesome vehicle. I mean, it's just it's not much to look at. It's kind of a hodgepodge of different technologies and different like designs, but it is super versatile, and we've done a lot with it, and I think we can do a lot more with it too. So
now, Ben, it's we've only got a few minutes left here, and so normally we'd go through some kind of like fast like round of questions, but before we get to the rapid fire questions, can you tell us a little bit about Gumby hanging out there on the for the eagle-eyed viewers? You may have noticed a little green gentleman hanging out there.
Right there.
Yeah.
Yeah.
What's going on there?
So, I don't really know. Canute, Brecky's the chief pilot for Doc Ricketts. He brought it in one day, and I'm not really sure why, but he did. And he put it up there. I think all the ROVs have had some mascot or another for years. I think Ventana has olive oil from Popeye and olive oil.
Yep.
And anyway, so yeah, Gumby's been with us for several years now.
A key part of the trimming of the vehicle, right? Just like it was the only thing that worked was this Gumby character to level everything out, right?
You gotta have somebody on board.
Exactly.
Fine.
Okay, let's go to Emily here for just first round here of some rapid fire questions, then we'll wrap up.
All right. First rapid fire question for you, Ben. How many staff does it take to fly the Doc Ricketts?
We have 5 pilots, 2 mechanical guys that do hydraulics and welding, all that stuff, and then 2 electronics / software, and then 1 chief pilot who handles scientists.
All right. Question number 2. What is your favorite animal to find when you're on a dive in the deep sea?
Oh, well, I'm still looking for the whale. But I love it when sharks come up and check us out. I love it when big squids come and check us out. And of course the vampire squid's always fun to watch. I also like bioluminescent stuff, like glow in the dark. Stuff is really cool.
All right. Question number 3. Has the Doc Ricketts had any hitchhikers over the years?
Yeah. Every once in a while we get a squid that comes that wants to hang on for a while. Yeah, it's better if they let go early.
All right. This is one of my favorite ones, the hard-hitting questions that we've gotten from our viewers today. Ben, what do you eat when you're at sea for weeks or months at a time?
Uh, well, we have a cook on board, Patrick, who makes us breakfast, lunch, and dinner. And so he's got a menu that he basically rotates through. So it's pretty much the same thing every time. There's a lot of uh, like Kraft macaroni and cheese sometimes, and hot dogs, but there's also like lamb, and he likes to make lamb and salmon and things like that. He does a really good job with all that stuff. So.
Cool.
Awesome. All right. And then I have one last question here for you. And it's okay if we take a little bit longer to answer this one, because I think it's a really cool part of what you are doing over at MBARI. Where do we get a robot like the Doc Ricketts?
Oh, well, you can try and do what MBARI did the first time and make your own, but that's really difficult and it's hard to keep maintained. So the second time, I think they learned their lesson a little bit better. They went and bought an industry one. So Doc Ricketts is actually purchased from a company called Soil Machine Dynamics, SMD. And they make these for the oil and gas industry. So fortunately, they this is not set up for oil and gas. They built us a custom control interface with a lot of hooks for extra sensors and things like that. And then we were able to go and modify it from there to make it good for science. And so and it's much better to do it that way, because then like SMD is handling the spares and upgrades and stuff like that that are like intrinsic to the system, like the control system or the thrusters, for instance. Like they keep track of all those parts, and when something breaks, we just, instead of having to go resource all those parts on our own, we just go to them and say, hey, send us a thruster.
Nice.
So.
And then maybe one final question here for you, Ben, for anyone out there who's watching this right now and wanting to get into it. If there are mate competitors that are watching, what would you tell someone who is watching this and really wants to get into this world? Everything that you're saying is just vibing with them right now, and that's like, oh, I want to like do what Ben is doing. What would you tell someone who's watching how to get into it, and then what this kind of work means to you?
Oh wow, well, yeah, it's the job is not for the faint of heart, for sure. You go out to sea for a long time away from friends and family, and it can be tough for that. It's just tough to be on a boat. I mean, the flyer is about the size of a basketball court, so being on a boat that size with almost 30 other people for weeks at a time can be very challenging. And so, yeah, you have to be able to get along with people really well, and especially in high stress situations, and work through problems together. You can't stop learning. You have to keep going, and so you have to keep driving yourself to learn and learn and learn, and be excited about learning, and so, yeah, it's kind of a nonstop thing. You just have to keep running hard. I don't know. It's been a really good experience for me. I'm kind of that way. I need to keep working and keep running hard to be happy, and so this is a good job for that.
Awesome. Cool. All right, well, let's get the gallery back together. The crew is here. They've been answering your questions diligently. Thank you so much, Ben, first of all. Amazing. Thank you so much for all of that work.
No worries.
The models and everything. It's so cool. Again, sketchfab.com/MBARI. Thank you, Emily, for all of the amazing questions from the audience there. And then thank you to the rest of the crew that was answering questions. Thank you, Susan. Thank you, George. Thank you, Cassie, so much. With that, everyone, thank you so much for tuning in to this Mysteries of the Deep broadcast. More of these videos are available on MBARI's YouTube channel and on our YouTube channel as well. They're also available as VOD over on Twitch. If you're watching on Twitch, hello, everybody there. But thank you so much for watching, and we hope to deep see you all again very soon. Thanks, folks.
Bye.
Bye.